Okay, I'm sorry for the delay. We are about to start now. This is not working. Okay, everyone, let's begin then. So trigonometric functions, that's what we want to do in this class, how to find range of trigonometric functions. So if you've looked at the worksheet, there's this other type of question in which they ask you about trigonometric functions. You have a function given and you have to find the range of that function. For instance, let's start with this question number 4 from the worksheet. This is question number 4 from the worksheet. Let's have a look at this. So we're done with all the other functions concepts already. There's transformations left. That's what we will be doing tonight at around 10:15, inshallah. Function, I'm sorry, my bad. Tonight we will be doing more practice questions and functions. Tomorrow we will be doing function transformations. But for now, let's look at this last type of question apart from transformations that you would have to deal with. We have done trigonometry already, but sometimes the trigonometric question comes along with functions. Let's see how to deal with problems like these. Now it says a function f is defined by f of x equals 3 minus 2 sine x. Now this is just a slightly different way of writing functions. So just like you have f of x equals 3 minus 2 sine x, there's another way to write this as well. F of x can also be written like this, that f is a function of x, which is 3 minus 2 sine x, right? So it's another way of writing f of x. Okay, so don't get confused by that. It's just f of x. Now it says f of x equals 3 minus 2 sine x. This is a function that you're given. And you're given that x is between 0 degrees and 360 degrees. That's the domain that we have, friends. Okay, what we need to do is we need to find the range of f. And the first part, it says find the range of f. Now, how do you find the range of the sine function? Now, notice also that they're asking you to sketch the graph of y equals f of x in the second part. So before you even draw the sketch of this graph, you're basically asked to find the range of the function. All right. Now, one possibility in such problems is, and that sometimes makes this type of question easier, that you are almost always asked to sketch the graph of this function in that same question as well. So what you could do is you could do the second part first, sketch the graph using the table function on your calculator. Remember, we've done that in trigonometry, how to just make a table in your calculator using the table function for this domain. Once you have drawn the sketch, then you can just write the range of that afterwards. You have separate space for every part in the exam, right? So you do the second part first, sketch the graph, and then write down the range. Look at what is the highest point of the graph, what is the lowest point of the graph, and then based on that, you can write down the range of the function. That is one possibility. Okay, so that's one thing that you could do. Now, what would be a direct way of doing this without sketching the graph? This is how you would think about it. Range of f means values of y. What's the maximum value of this function? What's the smallest value of this function? That is what we want to look for. Now, the function is 3 minus 2 sine x, and the domain of the function is from 0 to 360. The function is sine x. Now, remember, sine completes one full cycle in 360 degrees, right? One full cycle of sine is completed in 360 degrees. And it goes like this. So the sine function would look like this. It would start from 0. It will go to -1. So you can say this is 1, this is -1. From 0, it goes to 1, then comes back to 0, and then goes to -1, and then comes back to 0 again. Right? That's what the function looks like. Now remember what the smallest value of sine used to be and what the largest value of sine used to be. The sine function always used to be between -1 and 1. So if you're talking about one full cycle of the sine function, it would be from -1 to +1, right? So the sine function would be between -1 and 1. The value of sine function, it would be between -1 and +1. Okay, so the least value of sine is -1, and the greatest value of sine is +1. Now, in this function, what's the variable that you have? The only variable is x. And you know what the smallest value of sine x is and what the largest value of sine x is. All you have to do is look at these extreme values of sine. Sine has these two extreme values, -1 and 1. All you have to do is look at what happens when the value of sine x is equal to 1, and look at what happens when the value of sine x is -1. One of them is going to give you the maximum value, and the other one is going to give you the largest value. Okay, so try, for instance, first of all, sine x equals 1, and see what your function gives at that value. Right? These are the extreme values for sine, -1 and 1. You first input 1 or -1, any one of the two, and see what the function gives you on that. So 3 minus 2 into 1, what do you get? You get 1 from that. 3 minus 2 is 1. And then what you do is, you input sine x equals -1. That's the other extreme value of sine. You input that. And that gives you 3 minus 2 into -1. That's 3 plus 2, which is 5. Now, whichever of these two is the smaller value, that's the lower limit of your range, and whatever is the larger value, that's the upper limit of your range. And you would say the range of this function, the range of f of x looks like this. It's between 1 and 5, right? So 1 is the smaller value, 5 is the larger value. So when sine x equals 1, that gives you the minimum value, right? Because we have a negative sign here. Because of that, that's giving us the minimum value. And when sine of x is equal to -1, that gives us the maximum value of this function. All you have to do is put sine x equals to 1 once, and then input sine x equal to -1. The values that you get, one of them will be maximum and the other will be minimum. All right, that's the range. Y is between 1 and 5, or you could write f of x is between 1 and 5. Both of them would work. Make sense? Any problem with this? Okay. All right, good. Now let's have a look at the second part. Now in the second part, it says, sketch the graph of y equals f. So now you have to sketch this graph. Okay. Now you have to sketch this graph. Now, how do you sketch this graph? We've done this in trigonometry before. What's the function? The function is y equals 3 minus 2 sine x, where x is between 0 degrees and 360 degrees. Okay, this is the function that you have to sketch. Now, there are two ways of thinking about this again. One way is, if you remember the sine graph and you understand transformations of the trigonometric functions very well, you could draw it directly, right? So I'll tell you quickly, because that's not what I would recommend to most people. But if you are comfortable with the shape of the graph and the transformations that you can have for sine, cos, tan, you could think like this. That sine graph looks like this. Then you multiply by 2, that increases your amplitude by 2, so it will become this, right? So the amplitude will become bigger. Then you have minus multiplying, that means it's going to be a reflection like this. And then you have 3 added, so it will move 3 units up, right? So this is how you could think of transformation, that this is how the graph would look like. Okay, so that is one possibility. If you understand what I did there quickly, then okay, you can draw it like this. If you are thinking what exactly was that, if you're confused, use the other method that I would recommend most people. All you have to do is use the table function in your calculator, right? We've done this in trigonometry before. Put this as a function, 3 minus 2 sine x. Put this in your calculator. F of x equals 3 minus 2x, 3 minus 2 into sine of x, making sure your calculator is in degrees mode. Put this in the table function. Now, what value are you going to start from? The start value you're going to input is 0. And then end is going to be 360. And then step, you can take a step of 90. If you want to be more precise, you can use 45. But I'll show you how 90 would work. So you'll make this table on your calculator. You don't have to copy that table here. You don't have that much time. In the exam, you would just look at the table from on the calculator and plot those values here directly. So let me now draw that graph. So once you have made that table, all of you should try that. Make this table on a calculator. We've done this in detail before. This is the y-axis. This is the x-axis. You have to go from 0 degrees to 360 degrees. Let's mark those points. You have 180 in the middle, and you have 90 here, and you have 270 here. And you've already seen what's the minimum value on your graph. 1, maximum is 5. So you have to have an appropriate scale for that. You need to go up to 5 on your graph. So let me extend this a bit vertically. Okay, so this is what the y-axis looks like. Let me label this now. 1, 2, 3, 4, 5. Now, once you've made the table in your calculator, you will have values for y when x equals 0, 90, 180, 270, 360. Right? You have got all of those values. Just plot them. All right. So when you input x equals 0, look at your calculator. So it has to draw it on my calculator quickly as well. So I have this in front. Table, and I have to input 3 minus 2 sine of x, brackets closed, start 0. In fact, if you have class fills, you have to skip g of x, remember? Skip that because there's only one function that we have to draw here. If you had two functions, you could use g of x as well. But otherwise, just skip that. Then start is 0, end is 360, step is 90, and I've got my table. At 0, my calculator is giving me 3. At 90, it's 1. At 180, it's 3 again. At 270, it's 5. And at 360, it's 3 again. Okay. And now if I remember my sine graph well, remember the sine graph looks like this, or if it's a reflection, it looks like this. It's one of these two possible shapes, right? So which one is it? The second one, it's going to look like this. This is what the graph looks like. That's the graph of 3 minus 2 sine x. So you have to remember the shape of the graph and then just plot your values in your calculator. You get a table from your calculator, plot those points and draw that and sketch that graph like that. Okay. So that's what you can do. So we've got the graph and that's it. That's the second part. Okay. If you are not sure about the graph, as in once you have these points and you are still not sure how the graph is going to look like, some people end up drawing it like this and then they're confused. Okay, what do I do now? You could take some more points. Instead of having a step of 90, you could take a step of 45, and that will make it clear what the graph shape looks like. Okay, because you'll have points at 45, 135, 215, and so on as well. That is one possibility, but I would recommend that you remember the shape, the possible shape, and then just plot these points, join them, and you get your graph. Any problem with this? Any questions, anyone?
No, sir.
Okay, that was the second part. Now let's look at the third part. Now it says a function g is defined by g of x equals 3 minus 2 sine x. You see, it's the same expression as before. And it's defined for x between 0 degrees and a degrees. So x is between 0 and a. And what we have to do now is, it says a is a constant. State the largest value of a for which g has an inverse. Now remember, when a function has an inverse, what's the condition for that? A function has an inverse when it's a one-to-one function, right? So we basically need to figure out what's the largest value of a for which the function would be one-to-one. Okay, it's the same expression. But domain now is from 0 to a. So we're starting from 0. We have to see what could be the largest value of x until this function remains one-to-one. Now, how do we think about this? We have the graph of the function. And we can see, okay, we have to start from x equals 0. We have to start here. Now, how far can we go until this remains a one-to-one function? Now, how far can we go? If we go like this, and up to 180, for instance, is this one-to-one?
No.
It's not one-to-one, right? Because it fails the horizontal line test. So we have to stop somewhere before. When do we stop? Remember, we said one-to-one functions cannot have a turning point in the middle anywhere. So when you start from here, you would have to stop at the turning point. If you were to go any further than the turning point, the function would not remain one-to-one. If you were to go like this, then we could draw this horizontal line that cuts the graph at 2 points in the yellow part. That means it's not one-to-one. So we can't go beyond the turning point, right? Just like in quadratics as well, we looked at similar questions there in which the largest value was at the turning point. So what do we say then? The largest value of a for which g has an inverse would be 90 degrees. What's g of x? G of x was 3 minus 2 sine x, right? And the domain given was from 0 to a. We say the largest possible value of a for which it would remain a one-to-one function is 90 degrees. You can't go beyond that, okay? If you were to stop before 90, that's also fine. For example, if you were to stop at this point, this is also one-to-one. However, that's not the largest value of a, right? You would get maybe like 45, 50 here. The largest possible value would be 90, okay? All right, let's look at part 4 now. Now, part 4 says, when a has this value, obtain an expression in terms of x for g inverse of x. Now we need to find the inverse of this function. We have g of x, we need to find inverse of that. There's nothing complicated about this. We just apply our standard method. Let g of x equals y. So replace g of x with y, and that will give you y equals 2 minus sine x. Now make x the subject, and that gives you sine x equals 2 minus y.
Sir?
Yes?
Sir, it's
Okay, I'm
3
sorry.
minus 2 sine x.
Yeah, I'm sorry. I wrote the function wrong. I'm sorry about that. So it's 3 minus 2 sine x. Okay, so it's 3 minus 2 sine x. What does that become? Y equals 3 minus 2 sine x, and then 2 sine x equals 3 minus y, and then sine of x equals 3 minus y over 2. X equals sine inverse of 3 minus y over 2. All right, and now we write down this in the inverse form. We say g inverse of x, therefore, should equal sine inverse of 3 minus x divided by 2. Okay, so that's how we find the range of trigonometric functions and their inverse. Okay, now that's one possible type of question you could get here. Any problem with this?
No, sir.
Okay, let's have a look at another question now. This was question number 4 from the worksheet. Let's try another one. Okay, question number 19 from the worksheet. Again, this involves a trigonometric function. In this case, it's a tan function. Let's see how to think about this. Okay, question number 19 from the worksheet. Now, there is a slight misprint here. This is half x, okay? Inside tan, you've got half x. Okay, let's try this now. It says a function f is defined by f of x equals 3 minus 2 tan of half x for x between 0 and pi. We need to state the range of f. So we need to find the range of this function now. F of x equals 3 minus 2 into tan of half x. Okay. Now, how do you find the range of this function now? From 0 to pi. Now, remember the extreme values that we had for tan? If tan completed one full cycle, the range is basically infinite, right? It has no lowest point, no highest point. It goes from negative infinity to positive infinity. So if it was to complete one full cycle, we would say the range is negative infinity to positive infinity, but that basically means all real values, okay? If tan was completing one full cycle. But in this case, we are given that the domain of this function is from 0 to pi. It's from 0 to pi. Now it's not completing one full cycle. So how much cycle of tan is completed here? We need to think about that. Remember, this one full cycle for tan was 180 degrees or pi radians. This is half of x. What does half of x do? When you divide x by 2, if you remember your transformations from trigonometry that we did, if you divide x by 2, what happens to period? It multiplies by 2. So the original period, which was pi, that becomes 2 pi. So if it was just tan of x, 0 to pi would be one full cycle. However, this is tan half x. One full cycle in this case would be 2 pi radians, not pi radians. So it's not completing one full cycle. So how do we think about this? We could think of what happens at 0 and what happens at pi. Because remember, the tan graph does not have any turning points. It goes like this. It's either like this, or it's like this, or this. There's no turning points here as such. So what we do is we just look at what happens at the end points. And one foolproof way of doing this is make a table for this on your calculator. And that will help you understand how this function is, how the y value of this function is changing from x0 to pi. So you could just input this in your calculator, just like before, look at what different values you get at different points in this region. First of all, let's start with the extreme points. So if, for instance, x was 0, let's see what happens in that case. If x was 0, you would get 3 minus 2 into tan of half into 0. What does that give you? 3 minus 2 into 0, that will be 3. At 0, you're getting 3. What if x was pi? That gives you 3 minus 2 into tan of half into pi. What does that give you? If you put this on your calculator, what do you get? You get an error for that. All right. When you put this in your calculator, you get an error for that. So how did we used to think about such problems? It says less than pi. So you would try a number that's very close to pi, maybe. So pi is 3.14, right? So you could try what happens at 3.1. Let me try that. 3 minus 2 into tan of 3.1 divided by 2. And that's giving me 2.94. Okay. 3 minus 2 into tan of 3.1 divided by 2. Okay, now this is giving me 2.94, but let me try another value that's closer to that, 3.13. It's also going to 2.94. There's something wrong that I'm doing. This is degrees. Okay, I'm sorry, my calculator is in degrees mode, so you have to be careful about this as well. This is radians. So my calculator was in degrees mode from the last question. So it's giving me a different value. So I'm just going to change that unit. Okay, 3 minus 2 into tan of 3.1 divided by 2. And that's giving me minus 93 point something. Okay, that's a large negative value. At what point? When x equals 3.1, I'm getting minus 93. Now, if I take this closer to pi, so 3.1 is pretty close to pi. Pi is 3.14 something, right? So I could try, for instance, 3.13. That's giving me 3.13 is giving me minus 342. And that should kind of tell you a pattern. This is negative 93. This is negative 342. So what is happening as we go closer and closer to pi? This number is basically going towards negative infinity. So when x equals 0, the value of this function is 3. When x is getting closer and closer to pi, we tried pi. Pi was undefined. At pi, the function was undefined. But try a value that's very close to pi, 3.13, for instance. That gives you a large negative value. That means at pi, the function is going to approach negative infinity. Remember, it's going to be that part of the graph where the function goes like this, towards negative infinity. In fact, on this side, it will be negative. The other side, it's minus. So it will be like this. Okay, but you can just put this on your calculator, try a value that's very close to pi, slightly smaller than pi, and that gives you a large negative value. That means it's negative infinity. Another possibility could be you could draw a table for this on your calculator, just like you did for the previous question when you were supposed to draw the graph. If you were to try this in your calculator with a small step, relatively small step, so this gives me 3 minus 2 into tan of x over 2. Now, if I start from 0 and end at pi, and step, let's say if I take a step of maybe pi over 8 or pi over 16, a small step, and make a table, you can see the pattern in the table. So I'm getting values like this: 3, 2.8, 2.6, 2.3 for values of y, 2.17, 1.9, and so on. It goes to minus 0.741, then minus 1.28, minus 3, minus 7, minus 17. So it's going in the negative direction. So your calculator will kind of give you a pattern using the table function as well. And that could also make you understand what the range of this graph, what the range of this function looks like. So now you could say either y is between negative infinity and 3, because when x was 0, this was given as 3. Or you could just write it like this: y is less than or equal to 3, and that will be enough. Less than equal to 3 means it's going towards negative infinity, right? So you could write this range down either of these two ways. Does this make sense?
Yes, sir.
Sir,
Yes.
sir, for trig function, we can always look it in the calculator by table function. The
Yes, you
range.
can try that. Yeah, you can try that. If you take the domain very small, it would work. Okay. Take a very small domain. Sorry, not domain, step. Take a small step so that you get a large number of possible values, and that will give an idea of what the range should look like. Okay, but for sine and cos functions, it's pretty straightforward, because you know that if the cycle is completing, sine x has to be between -1 and 1. Cos also has to be between -1 and 1. So you can just try what happens at -1, try what happens at 1, and that will give you the extreme values of the function. So in that case, in case of sine and cos, it's relatively straightforward. Now we'll also see what happens in case of sine square and cos square in a few minutes. But this is what happens in sine and cos. For tan, you could use the table function in a calculator. Okay, now let's try this one. Part 2. It says state the exact value of f of 2 pi over 3. In fact, I think you can try the rest of the parts now. We understand the range. The rest of the parts are simple trigonometry. I'll just tell you about part 2, f of 2 pi over 3. I'm not going to spend time sketching the graph. You can do that using the table function. F of 2 pi over 3. What's that? 3 minus 2 into tan of x over 2. So you can say 2 pi over 3 divided by 2. Okay. Now that gives you 3 minus 2 into tan of 2 pi over 6, or you can say pi over 3. I'll just evaluate pi over 3 on your calculator and see what that gives you. 3 minus 2 into tan of pi over 3. Do that on your calculator. Tan pi over 3 is tan 60. I think it should give you under root 3, right? Let me confirm this. Tan of pi divided by 3, that's under root 3. So that's the exact value, 3 minus 2 under root 3. Okay, that's what we were looking for in the second part. In the third part, it asks you to sketch this graph. You can use the table function, sketch the graph. You should remember that the graph is broken and you have asymptotes, right? So just remember that, try sketching this. In the last part, it says, obtain an expression for f inverse of x. Now this is the part that relates to functions. Let's do this quickly. Part 4. F of x is 3 minus 2 tan of half x. The domain of this function is from 0 to pi. This is the function that we are given. We need to find the inverse of this function. Okay, so how do we do that? Replace f of x with y. You say let y equals f of x, and that gives you y equals 3 minus 2 tan of half x. Now you need to make x the subject. You can take the tan term to the other side. That gives you 2 tan of half x. That equals 3 minus y. Divide 2 on the other side. Tan half x equals 3 minus y divided by 2. Now you need to take tan inverse, right? That gives you half x equals tan inverse of 3 minus y over 2. When you multiply 2 on the other side, it becomes 2 tan inverse of 3 minus y divided by 2. And finally, you can write down the final result, the inverse function, in f inverse of x form. F inverse of x equals 2 tan inverse of 3 minus x divided by 2. Make sure to change this variable on the right side as well. Don't leave it as y. That will make you lose 1 mark. You have to write your answer in terms of x. So f inverse of x equals 2 tan inverse of 3 minus x over 2. That's the inverse function that we were looking for. Is that okay? Any problem with this?
No, sir.
No? Okay, let's have a look at another one now. Now, sometimes what happens is you end up getting square functions. Let's see how to handle problems like that. Now, again, I'm going to take an example from the worksheet. Okay, question number 14 from the worksheet. Let's try this. Okay, Question number 14 from the worksheet. It says the function f is such that f of x is 2 sine square x minus 3 cos square x for x between 0 and pi. Okay, so now we have a function that has sine squared and cos squared. Let's see how to deal with functions like these. F of x equals 2 sine square x minus 3 cos square x, and the domain is from 0 to pi. Okay, domain is from 0 to pi. In the first part, it says express f of x in the form a plus b cos square x, stating the values of a and b. So first of all, you need to convert this function to only in terms of cos squared. Now, how can we do that? We have sine squared here. We can use sine square equals 1 minus cos squared to convert this. What does that give you? F of x equals 2 into 1 minus cos square x minus 3 cos square x. And that gives you 2 minus 2 cos square x minus 3 cos square x, which is 2 minus 5 cos square x. This is what f of x turns out to be. Okay. 2 minus 5 cos square x, this is f of x. Okay, that's the first part. It says state the values of a and b. If you compare with this form, it's a plus b cos square x. That means a is equal to 2 and b is equal to minus 5. Okay, that's the first part. Again, that was just simple trigonometry. Now, in the second part, it says state the greatest and least values of f of x. So essentially, they're asking you for the range of f of x, because that's what that's how you find range of functions, right? You're looking for the least value of the function and the greatest value of the function. That's what you're looking for. Okay. So how do you find the range of this function? Now we have sine square and cos square. Now, first of all, remember, we have already converted this function to this form, 2 minus 5 cos square x. Let's use this form, and then I'll tell you why you can't use the other form. We'll talk about that. But first, let's say, since we've already converted it to this form, 2 minus 5 cos square x, let's use this form to find the range of the function. Now, how do you use this function to find the range? Again, let's talk about that same idea that we used for, let's use that same idea that we used for sine function in the first, in the very first question that we did. The domain of the function is from 0 to pi. Okay, from 0 to pi, that's the domain of the function. Now, what does the graph of cos looks like? Cos of x. What does the graph of cos look like? It looks something like this, right? You have to remember the shapes of the graph. This is the graph of cos function. Now, it starts from 1. It goes to 0 when it's pi over 2. And it goes to minus 1 when it's at pi. The domain of the function that we're given, what's that? The domain of the function is from 0 to pi. That's what they've given us, 0 to pi. So which part of this cos function is valid? This is not the graph of 2 minus 5 cos square x. Remember this. I'm just thinking about what the maximum and minimum value of cos is. All right. So the cos graph looks like this. Now, which part of this function is valid when x is between 0 and pi? Only this part. Now, in this part, what's the least possible value of x? Least possible value of cos, -1. What's the largest possible value of cos x? It's +1. So the minimum value of cos is still -1 and the maximum value is still +1, even though it's not one complete cycle, but still the minimum and maximum values of cos are -1 and +1. Now, if it was just cos x and not cos square x, we could just directly input cos x equals 1 once, and then we could input cos x equals -1. We could just input these values one by one, and we would get the range of the function, the least value and the greatest value. But here the problem is we have cos square x. Now, what happens when you have cos square x? Let's think about this. If I were to input cos x equals 1, let's see the result that I get from that. If I input cos x equal to 1, that gives me 2 minus 5 into 1, 2 minus 5 into 1 whole square, and that's -3. If I input cos x equals -1, now since cos has a square on it, 2 minus 5 into -1 whole square, that's also giving -3. -1 and 1, both of them are going to give me the same value. The reason for that is we have cos square. If we input 1 in that, it's still 1. If we input -1, that's still 1. Okay. So when you have a square function like this, -1 and 1 are not going to work. -1 and 1 are not going to work. They are not going to give you the range in this case. So what do we do instead? Instead of -1 and 1, we should do something else. When you have square function, let's see what that something else is going to be. I showed you how the graph of cos x looks like. Right? This is how the graph of cos x looks like. Now, you don't necessarily need to know the graph of cos square x as such, but if you just think about it, what would that look like? If I were to just copy this, what happens when we square cos of x? What happens when we square cos of x? Let's try to understand that. Just focus on the part from 0 to pi, right? Because that's the interval that's valid. Now, when cos of x is 1, what is the value of cos square x going to be? Square of 1 is also 1. So it's still going to start from 1. Okay. So it is still going to start from 1. Cos square x is also going to start from 1. So it will start from the same value. When cos x is 0, what about cos square x? Cos square x is also going to be 0. So at pi/2 as well, it has the same value. At 0, it's the same value. At pi/2, it's the same value as cos. However, when cos of x is -1, what about cos square x? -1 squared, that's going to become 1. So at pi, the cos square function is going to have this value, 1. So the cos square graph is actually going to look like this instead. From 0 to pi, it's going to go like this. It's going to go from 1 to 0 and then come back to 1 like this. Instead of going below the x-axis, since it's a square function, it cannot go below the x-axis. The range of cos square x is actually going to be from 0 to 1 instead of -1 to 1. So in cos of x or sine of x, we use -1 to 1. When you have square of this, when you have cos square x, instead of -1 to 1, all you have to do is use 0 to 1. So instead of putting 1 and minus 1 here, what you should do is see what happens when cos of x equals 0 or cos square of x equals 0. It's the same thing. What does that give you? That gives you 2 as the result. So in cos square or sine square, the extreme values you use are going to be 0 and 1 instead of minus 1 and 1. And it's the same for sine as well. For sine x as well, you would use minus 1 to 1 if it's one complete cycle. And for sine square x, if it's one complete cycle, you would use 0 to 1. Okay? If it's not complete cycle, then you have to look at the graph and see what's happening. But if it's complete cycle, then this is all that you have to do, input these values. So for sine square x, so for cos square x, for instance, all you have to do now is input cos square x equals 1, input cos square x equals 0, and see the values that you get from that. You're getting minus 3 here and 2 here. So what's the range of this function then? Range of f of x or y, what is that? You'll say y is between minus 3 and 2. In fact, they were asking us for the greatest and least values of f of x. So you can say least value of f of x is 2, is minus 3. And the greatest value of f of x, that will be 2. Okay. Now, we spent quite some time trying to understand the logic of it. Now, what you have to do is, when you have a square function like this, cos square or sine square, input that function equal to 0 once, and input that function equal to 1 once. Whatever is giving you the smaller value, that's the least value of the function, the lower limit of the range, and whatever is giving you the larger value, that value is going to be the upper limit of the range. And that's how you can find the range of functions like these, 2 minus 5 cos square x. Is this point clear to everyone? The lower limit of the range, and whatever is giving you the larger value, that value is going to be the upper limit of the range. And that's how you can find the range of functions like these, 2 minus 5 cos square x. Okay, so I can hear myself back. Okay. Does this make sense to everyone? No problems?
Yes, sir.
Okay. Now, the question is, could we do the same thing on this original function? So if they had given us f of x equal to 2 sine square x minus 3 cos square x, if they had given just this and asked us to find the range of this function, given that x is between 0 and pi. Now, since we have sine square x and cos square x, could we say that sine square x is supposed to be between 0 and 1? And cos square x is supposed to be between 0 and 1? So one idea could be to input 0 in both of them, and another idea could be to input 1 in both of them. Will that work? Then once input 0 in both, once input 1 in both, to find the range. What do you think? Could that work? That the least values of sine and cos are 0. So input 0 in both to get one extreme value. And then the greatest values of sine square and cos square are 1. So input 1 in both to get the maximum value. You think that could work? Yes? No?
No, because they don't start in the same area on the graph. So we're technically saying that they intersect when they don't.
That's very good. So basically, if we input 0 in both of them, we are basically saying they become 0 at the same point. But that's not what happens. The value of sine x and cos x cannot be 0 at the same time. They cannot both be 0 at the same time. That's not possible. Similarly, they cannot both be 1 at the same point. Both of them have the least value 0. Both of them have the maximum value 1, sine square and cos square. However, they do not have those maximum values at the same value of x. They don't have the same. They have the minimum values at the same value of x. So we can't input 0 in both of them at the same time. We can't input 1 in both of them at the same time. That is not going to work. So whenever we have to find range of such functions, we always have to convert this function to a single function. You either convert it to sine square or cos square. Let me write that down here. For finding range of such functions, always convert them to either only sine square x or only cos square x first. Only then you will be able to find the range of this function. You can't find the range of the function without converting it to one function first. Okay? Okay, great. Now, I hope that makes sense. In this case, they asked you to convert this function to this form in the first part already. And then in the second part, you could use that. If the first part was not there, if they had not asked you to do the first part, you would have to do that anyway. You would have to convert the function to either sine square or cos square yourself. Without that, you would not be able to find the range of the function. Okay? Okay, good. I hope that makes sense. Let's look at the last part. Now, the last part is relatively straightforward. We've done that in trigonometry, so I think you should be able to do that. It's f of x plus 1 equal to 0. It's just function notation used with trigonometry. This is the equation that they want you to solve, f of x plus 1 equal to 0. We know that the domain of the f of x function is from 0 to pi. So the values of x that you're going to be looking for are going to be from 0 to pi. F of x is 2 sine square x. In fact, you've converted it to this form already, 2 minus 5 cos square x. You would use that here, 2 minus 5 cos square x plus 1 equal to 0. That's going to give you cos square x equal to 3 over 5, right? 3 over 5 will take square root on both sides, but remember when you take square root, you have to put plus minus, so it will become square root of 3 divided by 5 plus minus, so that's plus minus 0.774546. In fact, you find the basic angle first by writing it as cos alpha equal to the positive value on the right side, 0.7746. You'll find the basic angle tan inverse of this answer. That's giving me, and I'm sorry, let's do that again. Cos inverse of 0.7746, 0.6847. That's the basic angle. Then you think of quadrants. Since it's going from 0 to pi, cos x could be positive or negative. That means it could be any of the 4 quadrants. However, the interval is from 0 to pi. That means the third and fourth are not possible. You're only going to look at values in the first quadrant or in the second quadrant. So you say x is either equal to 0.6847 in the first quadrant, or x equals pi minus 0.6847 in the second quadrant. In the second quadrant, you would get 2.457. These are the two possible values of x that you get. All right. So that's just simple trigonometry. We've done many questions like this in trigonometry before. That's how you would do it. Okay. Any problem with this? Make sense? Okay, great. So no questions. Let's move on to the next one now. This was question number 14 from the worksheet.
Sir,
Yes.
sir, can you explain the range part again? My net was disconnected.
Let me see if I can find another question like that. Or Abdullah, you'd have the recording available. Could you just look at that, because there are 2 or 3 more questions that I want to do, and we're running out of time.
Okay, sir. Okay, sir.
Okay, I'll share the recording and you can do it. We'll have a look at that right after this. Okay. Question number 14, we are done with that. Okay. Okay, let's actually do another very similar question to this. I'll do this very quickly, just to give you an idea. So there's another in the worksheet like this. This is question number 2 from the worksheet. It also has squares like that. Okay, so you have this function f of x equals 5 sine square x plus 3 cos square x and the domain is from 0 to pi. Okay, and the first part, it asks you to convert it to a plus b sine square x. Okay, we could try that quickly. So you have to convert it to sine square x form now. You have to get rid of cos square. So what does that become? 5 sine square x plus 3 into 1 minus sine square x. And that's going to give you 5 sine square x minus 3 sine square x. That will be 2 sine square x plus 3. Okay, that's what you get from this. It says state the values of a and b. Now, it's in this form, a plus b sine square x. So you have to rearrange this and write it like this instead, 3 plus 2 sine square x. And now you compare with that form. You have a plus b sine square x. That means a is equal to 3 and b is equal to 2. Okay, that's the first part. That's all that you have to do there. In part 2, you have to solve an equation. Now, again, you've done this in trigonometry. It looks like it's going to become a quadratic equation. You can solve that quadratic equation. We've done many of those. I'm going to skip that part. We're doing functions. So let's move on to the last part, which says state the range of it. Now, how do you find the range of this function? Again, we have converted this to one single function already, right? So it was 5 sine square x plus 3 cos square x. We talked about this, that you can't find the range of this function unless you first convert it to a single function. And we have done that already in the first part. Now, when you're finding the range of the function, you're going to be looking at the form that only has sine square. That's 3 plus 2 sine square x. This is the form that you're going to look at. What's the domain of this function? The domain is from 0 to pi. Now let's start with thinking of sine x. How does the graph of sine x look like? The sine x graph goes from 0 to 1, and then from 0, then back to 0, and then minus 1, and then 0, like this. Which part of this function is valid? Only from 0 to pi. This is y, this is x. Only this part is valid from x equals 0 to x equals pi. Now, what's the least and greatest value of sine x in this interval? You can look at the graph. The lowest value is 0 and the highest value is 1. If that's the range for sine x, what about sine square x? That's also from 0 to 1, because this function is not going in the negative direction, on the negative side at all. So the square is also going to be from 0 to 1, like this. All you have to do now is input sine square x equal to 1 here once, and then input sine square x equal to 0 here once. That should give you the result. You can input sine x equal to 1 or sine square x equal to 1. Both of them will give you the same result. It doesn't make any difference, because square of 1 is also 1, square of 0 is also 0. Now, what does that give me? F of x equals 3 plus 2 into 1, and that's giving me 5. When it's 0, That gives me 3 plus 2 times 0, that's 3. So what's the range of this function then? You would say the range of the function is from 3 to 5. Okay, that's how the range of this function looks like. Any problem with this?
No, sir.
Okay, let's try another one. Let's make it slightly more complicated. Let's do a couple of more questions, then we end for today. For this class, we'll have another one tonight in which we will be doing practice questions on functions. Okay, so any question that you have from the worksheet or from any recent papers, bring them tonight. We will do them in that class, okay? Because tomorrow we need to start with function transformations, inshallah. Okay, question number 11 from the worksheet. Let's try this. Okay, so it says the function f is such that f of x equals a minus b cos x for x between 0 and 360, where a and b are positive constants. The maximum value of f of x is 10 and the minimum value of f of x is minus 2. So we have the maximum value of f of x given, the minimum value of f of x given. We need to find the values of a and b. How do you do that? You have the function f of x that equals a minus b cos of x. Now it's a cos function, right? It's a cos function. Is this cycle of cos completing here? It's cos of x, so there's nothing multiplying or dividing by x. And x is going from 0 to 360. That means it's one full cycle. If it's one full cycle, that means cos of x, therefore, is going to be between minus 1 and 1. We know that, right? It can't go beyond these values. So we know the minimum value of cos of x is minus 1, the maximum is 1. So one of these values is going to give us the least value of this function, the minimum value of this function, and the other one is going to give us the maximum value of this function. So all you have to do is input cos x equals 1 once and see what that gives you. F of x equals a minus b into 1, and that results in a minus b. And then you can input a cos x equals minus 1, and that gives us a minus b into minus 1, and that turns out to be a plus b. Now, one of them is going to be the maximum value, the other one is going to be the minimum value. And we are given that the maximum value is 10 and the minimum value is minus 2. Now, which one of these is going to be maximum and which one of these is going to be minimum? You see, the question says a and b are positive constants. So both a and b are positive. We know that. If a and b are positive, a plus b is obviously going to be a bigger number as compared to a minus b. If you're subtracting two numbers and they're both positive, and on the other hand, you're adding two numbers, when you add the numbers, the result is going to be bigger. So that means a plus b, therefore, is a maximum value, which is equal to 10. The question says that. A minus b is going to be the minimum value, which is equal to minus 2. So from this, you get two equations. You get two equations that a minus b should equal minus 2. That's one equation. And another equation should be a plus b equals 10. You can solve these equations simultaneously and you would get your result. So you could actually do this using elimination much quicker. So you could say a minus b equals minus 2. Let me actually just write them like this instead. So you have two equations. A minus b equals minus 2 and a plus b equals 10. We could do elimination. These two get cancelled. And we have 2 times a. That equals 8. The value of a turns out to be 4. Put this back in any one of those two equations. For example, the second one, 4 plus b equals 10, the value of b turns out to be 6. So a equals 4 and b equals 6. This is how we could find the values of a and b. Okay? Make sense? So now the function becomes 4 minus 6 cos x. In the second part, you just have to solve this equation, 4 minus 6 cos x equals 0 for x between 0 and 360. You can all do that. In the last part, it asks you to sketch this graph. Again, you can put this value, put the function in the table function on your calculator, start 0, end 360, and step 90, and you know the shape of the cos function. It should either look like this, or it should look the reflection of this like this. It should be one of these two shapes, right? You would draw that one of those two shapes depending on the points that you get. Okay. In this case, since it's minus cos x, you would get this one. The shape would look like this. Okay. You can do the last part as well. That's how you could do the first part. So I just wanted to talk about that in particular. This is one way of doing this. Input cos x equals 1 once, input cos x equals minus 1. One of them is going to give you the maximum value. The other gives you the minimum value. You get two equations. Solve those two equations simultaneously, and you get the values of a and b. Now, there could be another way of thinking about this as well, which is slightly trickier, although quicker if you're able to figure that out. Think about it. The function is a minus b cos x. So I'll just tell you this other method as well. In case you understand that, you could do this question using that as well. X is between 0 degrees and 360 degrees. Now it's trickier than the other one, as in this requires some thinking. So that means it's trickier. The previous one was just like putting values and getting the result. So there was not a lot of thought process involved there as such. Easier to do, although takes slightly longer. But another way to think about this could be, your question is telling you the minimum value of this function is minus 2 and the maximum value is 10. Now, if you remember your transformations, if the graph looks like this, from minus 2 to 10, so the graph is going from minus 2 to 10. Minus 2 is the least value, 10 is the maximum value, and you have minus here with the cos function. That means it's a reflection in x-axis. The graph is going to look something like this. This is going to be the shape of the graph. It's going to look something like this. Okay, when you draw the graph, this is what the shape would roughly look like. Now the question is basically telling you the least value is minus 2 and the highest value of this function on the y-axis, that is 10. So you know the least value is minus 2 and the maximum value is 10. Where is the baseline going to be? Right in the middle. Minus 2 plus 10 over 2, average of these two numbers, that is 4. That's going to be the baseline. Remember baseline? Baseline is the horizontal line about which the graph moves up and down. We discussed that in trigonometry. So that's the baseline. This number outside is supposed to be the baseline. So that's 4. So this gives you the value of A. A is 4. And then what was the amplitude? The number that the function was multiplying with, cos or sine, that used to give you the amplitude. B is the amplitude. Now, what's the amplitude of this function? If 4 is the baseline, amplitude is 6. So that means the value of B should be 6. And you can write down these values directly like this. A equals 4 and B equals 6. That's exactly what you got there as well. Okay, so thinking of graph and transformations, this could be another way of thinking about this. Okay.
Okay, sir.
All right, now let's look at one more. Maybe I'll just give you a hint of that and then we end. So there's one more question on the worksheet like this, I think. So I think we've done enough. So yeah, so one question very similar to this. Let's do the first part of that question as well, and then we end. Then tonight we do practice questions. Please make sure to bring your questions. If you haven't practiced until now, make sure to do that. Spend some time, spend a couple of hours before tonight's class and do the practice questions from the worksheet and from recent papers 2020 onward. Let me know if there are any problems. We'll have a practice class on functions tonight, inshallah. Question number 8. Let's try this. It says the function f is defined by f of x equal to a plus b into cos of 2x. And the domain is from 0 to pi, right? Again, it's radians, keep that in mind. It's given that f of 0 equals -1 and f of pi over 2 equals 7. Find the values of a and b. Well, it's not really a range function, actually. It's just a simple trigonometry question. It says that they're using function notation. Okay, so I'll just tell you what to do in the first part, but the rest of the two parts are even more straightforward. So all you have to do is, it says f of 0 equals -1. So f of 0 equals -1, that means when you input x equal to 0 in this function, the y value, the function is going to be equal to -1. So input x equals 0 in this, and put that equal to -1. So you have a plus b into cos of 2 times 0, that's 0, equals -1. That's one equation that you have. Now that becomes a plus b into cos of 0. What's cos of 0? Cos of 0 is 1. So you have one equation, a plus b equal to -1. So all I've done is I've input this point in the function. So f of 0 equals -1 basically means when x is equal to 0, y is equal to -1. F of pi over 2 equals 7 means when x equals pi over 2, y equals 7. All right. So you just have to input these values. So I've input x equal to 0 and y equals -1 here. And now what you do is you input x equal to pi over 2 and y equal to 7 now. So you say f of pi over 2, that should equal 7. And that will give you a plus b into cos of 2 into pi over 2. That's just pi. That equals 7. And what does that give you now? A plus b. This 2 and 2 get cancelled. Cos of pi is -1. So it becomes a plus b into -1 equals 7. And you get a minus b equal to 7. You get two equations. You solve them simultaneously, and you would get the values of a and b. Okay, you can try that. That's not very difficult. In the second part, it says find the x coordinates of the points where the curve intersects the x-axis. Once you have the values of a and b, you're looking for the x-intercept, put y equal to 0. So it will be 0 equals a plus b into cos of 2x. You just have to solve that equation. We have done that in trigonometry. Pretty straightforward. You can try that. And the last part, you have to sketch this graph. So the rest of it is just simple trigonometry. We've spent a lot of time on trigonometry before. So that should not be a problem. All right, so that's how you find range of trigonometric functions. That's what we wanted to do today. I hope that makes sense. I'll see you again tonight with some practice questions on functions. But that's it for now. If you have any quick questions, let me know. Otherwise, we end this class here. Any problems, anyone?
No, sir.
Sir, the
Yes,
past paper sessions you sent on the WhatsApp group chat, do we have to sign in? We have to fill out the form.
Yeah, so if you're interested in that past paper session, you have to fill that form out. Yeah. So the link that I sent there. Yeah. That's a separate session. That's a yearly past paper session. So that's starting from 13th of April.
Okay, sir. Thank you.
Okay. All right. So just a reminder, I have a past paper session starting from 13th of April, inshallah. So it's for all. It's for 4 papers: P1, P3, M1, and S1. I do not teach S2 currently, unfortunately. For those of you who've been asking. So P1, P3, M1, and S1. These are the 4 sessions that I'll be having. So there are going to be 3 types of sessions that we would have. We would, in some classes, we will be doing full-length papers, complete papers. So complete P1, complete P3, complete M1, complete S1, depending on which class we're talking about. Then in some sessions, we will be doing difficult questions. So for example, if you're talking about June 2023, for instance, for every session, the plan is that I'll be doing 1 full-length paper for every session, 1 variant, as in paper 3, for instance, has 3 variants, 3-1, 3-2, 3-3. We will look at which of the 3 variants has the lowest threshold. We will do that paper completely. And then for the other 2 papers, those of you who are registered, you will be telling me which particular questions you're finding difficult, and we will just do those difficult questions in another session. All right. So in one session, we will do the full-length paper. In another session, we will do 2 of the difficult questions from the other 2 variants. And then we'll have a couple of classes at least in which we will have just an open-ended session, especially right before the exam. So the night before the exam and maybe 2 days before the exam as well, of that particular component. For example, if your P1 exam is probably on 2nd May, I think. So on 1st May and 30th of April, we might be doing a couple of sessions in which it's just open-ended, as in you can come ask your questions, whatever questions you have from any of the past papers. So in the last couple of sessions, it might not be a very good idea to focus on one particular paper, but that what we'll do is I'll make it open-ended, so you can bring any questions that you have from any past papers, and we could discuss those questions. There are going to be 3 types of sessions. In one session, in one type of session, we'll be doing full-length paper. In another session, we'll be doing so that classes are going to be divided into 3 types. In one class type, we'll be doing full-length papers then every week. And in some classes that week, we will be doing difficult questions from some papers. And then towards the end, when you have the exam for that component, that particular component, the night before that and 2 days before that, we'll have like a session tailored to the people who will be attending that particular class. You can bring any particular question that you have from any past papers, and we will be discussing those questions in that class. All right, so that's the plan. All right, so that's it for now. I'll see you again in the next session tonight. Yes, Abdullah.
Sir, what will be the duration of the session? Like for 2 weeks or?
No, it will start from 13th and it will be until the night before each exam. So paper 1 session will be until 1st May, and then M1s will continue until I think 6th May. Your paper I think is in 7th. So for the night before the exam, for S1 it will continue until 12th of May. For P3 it will continue until 14th of May. So the night before each exam, basically. But
Okay,
what will happen is the papers that are coming earlier, for P1, for instance, we will have more classes in the first 2 weeks as compared to P3, for instance. So P1, P3, they will be in the same time start. So in the first couple of weeks, we will be spending 4 sessions on P1s every week and 2 sessions on P3 in the first couple of weeks until the P1 exam. And then once the P1 exam is done, then the next 15 days in that slot, in the next 2 weeks in that particular slot, you will be spending all that time on P3. And similarly for M1 and S1, we'll be focusing slightly more in S1 until the M1, I'm sorry, I said the other way around. Until the M1 exam on 7th May, we will be focusing slightly more on M1, so maybe 3 sessions in M1 every week and 2 on S1. And then after that M1 exam, we'll have all S1 sessions in that particular slot. So that's how the classes are going to be divided, kind of. Okay?
Okay, sir. Thank you, sir.
Okay, all right. Okay, so that's it. I'll see you again tonight, inshallah, again. Allah Hafiz.